Hello, welcome to this lecture on New Technology Programming 4. This is Learning Unit 4, and we'll be looking at programming with Jade, and in particular focusing on more advanced features of Jade. My name is Nsako Baloi, and I hope you'll enjoy this particular video lecture. What I hope to achieve by the end of this lecture is to be able to differentiate between ontologies and content languages, demonstrate a basic understanding of how to compose behaviors to create complex agent tasks, explain threaded behaviors in software agents, as well as the ability to illustrate the interaction of protocols. Another thing that we'll look at is the agent management system, as well as how one can start Jade from an external application. As you know that this is probably one of the most important aspects that one would need to use Jade for, as one can hardly really expect to use Jade directly from the IDE. Okay. So typically when you look at the Jade platform, there are various agents that pop up. The AMS, which is the agent management systems, is instantiated by default. This is because this is your management platform, really. This is where you create Jade. This is where you suspend, this is where you create agents, you suspend agents, etc. This is your typical management platform. And you've got a directive facilitator, which also comes up quite oftenly by default, but this is actually quite it's not a must that one should have a directive facilitator, and this is your typical yellow pages kind, where you can rely on the directive facilitator to know what agents exist and what services they provide. You also have got the remote monitoring agent, as well as other agents like your sniper agent and so forth. Okay. I know that I have sent some videos in the past that look strictly into some of these concepts, and therefore I will not waste much time on them here. Okay. So there are various tools provided by Jade, as well as various libraries that one can use to develop classes. Now, all the agents that we'll be dealing with basically will be Java-based. One could rely on the command, could run them from the command line or directly from the GUI. Would prefer for now mostly the GUI method, as we've been using in class, but you would notice that it may then become more important from a command line kind of command perspective for running agents using from an external application. Okay, so when you program agents, you may use any development environment, as you're already aware. You can define agent behaviors so that they can be able to do whatever it is that you want done. There are three primary behaviors that we have already spoken to in the previous lecture. And agent communication is, as you know by now, achieved through the ACL, which stands for Agent Communication Language. And then you also have got the publication and discovery of agents, so that they can be utilized by other agents, which is the directive facilitator. And you know by now that perhaps the most important package that one is to import to use to develop agent software in Jade is the jade.co.agent. Okay, we have looked at this example in the past, and this is just a refresher to remind you that you need to import jade.co.agent to be able to then, when you create your class, extend it to an agent. Okay, so this is very important, otherwise it is not an agent that you are dealing with, and you won't be able to use that unless you've got the correct import. Then you do your setup, and here it was just a simple hello program, and with the agent giving its name. All right. So I know that some people would like to use environmental variables to set up Jade so that they can call it from the command prompt, and to be able to achieve that, there are certain things that you'll need to do. You will need to, for instance, configure the class path, but I will not go much into this because this information you will have to refer to. But it's important to look at the various things that you will need to then point Jade to. And I mean, these are precisely the same things that one would have needed when they're setting up an agent to run on an IDE like you have seen in class with NetBeans. Okay, but I'm just saying here on this example where one had to effectively set up the environment to be able to run Jade from the command prompt. This is what one would have needed to do, and this is courtesy of Dr. Jabumzwenya. Okay, so basically what you would need to ensure that you have ready before you can run Jade, you need to have your Java installed, either JAR or JDK. You need to have the path set, and you need to make sure that you extract Jade to a particular folder, preferably C. It's on the C drive. You need to set up the environmental variables, and to start Jade, you need to say java j.boot -GUI, and that you can effectively do on the command prompt. As for doing it on the GUI, we have done that several times in class. In fact, I've sent you some material that you can rely on. Okay. And to run that command, of course, you need to already be on the path where you have got your Jade stuff. And this is just another example of what would have happened there. What you need to set up, so your Jade.home and as well as the class path. Those are the basic ones that you need to set up. And you'll notice that on the class path, you have pointed to the j.jar, you have pointed to the j.tools.jar, you have pointed basically to the http.jar, iiopip.jar, etc., and the common codecs. And you know that there are some of these which we also use when we're in class. The important thing here being that the basic ones that you'll require, for instance, your j.jar, your common codecs, etc. It's not all of these that you may require to run a basic program, but some of these you find that, like your http.jar, when you start developing websites, those you then require. Okay. All right. You'll have seen this, that after bringing up the GUI, when you run Jade, it will bring out this text basically, which basically that first red circle part just showed you where the listening port, and these here show you the various agents that are being initiated, okay, or initialized. And then down here you have your main container as it comes by default, that is already created. So that message basically communicates that. So just so that you have an idea of what some of the content in this message speaks to, and if there are any errors, you will typically also see the errors being there. Sure. So you should be by now familiar with this screen, which is the GUI that pops up. So when you say -GUI in whatever command that you want to run Jade, this is the GUI that you're basically referring to, and that main container at the bottom, the AMS, def, and RMA, which come typically by default, although like I told you, the things like your df need not necessarily be there. And you'll also notice that agents run on a particular platform, and there can be multiple platforms, and in each platform there has to be a main container, but there can be many other containers, and we'll talk, for instance, about some of these concepts when we start discussing agent mobility. Because when you get to agent mobility, you'll then notice that agents can migrate within a platform from container to container, or they can migrate from one platform to a different platform altogether, which these platforms, by the way, could also be in different machines and not necessarily be on the same machines. And even a single platform, could run across multiple machines. They just have to be registered to that particular platform. Okay, ontologies. So ACL messages are basically included in the content slot, and what you would be dealing with are typically normal strings of information or a raw sequence of bytes. So with the content language, all it does is to describe the syntax used by agents to communicate. That's all that a content language does, almost like a human language, which just dictates the rules one needs to engage by in using that language, and not so much the content of the language, because you can make up your sentences in any way that you want. But this is just to establish basic rules that one needs to focus in the form of syntax for agents to communicate and understand each other. Okay, an example of that you can think of, some of those rules would be your communicative acts like your inform, etc. All right. So there's no specific content language that is mandated. So you can rely on any of the different languages that are there, and semantic language is basically recommended in that it is human readable. Okay. An ontology itself, though, provides a description of the concepts in the content. So if you want to think of it, ontologies are domain specific. So if you're dealing with the domain of weather forecast or you're dealing with the domain of transportation, the concepts used will relate to that particular domain because they are domain specific. Okay. The other thing that is quite important is that to notice that whilst ontologies are domain specific, the content language itself, because it's generic, is high level, it's not domain specific and therefore it's domain independent. When you look at an ontology, to be able to use ontologies in Jade, you will need to call in the jade.content.onto.ontology class. All right. So you see that jade.content package being used here. Right, there are different types of languages that one can use for content, SL, Lib, XML, and many others. And like we've already said, you can really use any of them. Okay, some of the stuff that I discussed a bit earlier, to say you start with a raw string or a sequence of bytes that will need to be processed through Jade and appear on the other side basically as information that is represented as Java objects, because that is what would be understood on the other side. So that is basically what this particular screen talks to. So you start with, on the content slot, you start with your normal ACL message in that string format that you'll typically have it. And then through Jade support for content languages and ontologies, you'll then be able to translate that into the equivalent of what would be Java objects that can then be processed inside an agent. Okay. We've dealt with the main types of behaviors in the previous lesson, and in this particular lesson I want to delve a bit deeper into the concept of behaviors, and then we've got what we call composite behaviors, and in there we've got what we call complex behaviors, which basically have got child behaviors which may either be simple or complex. Okay, when one deals with complex behaviors, or when complex behaviors are active, it is the complex behavior that decides which child should be active, and it then schedules the relevant behaviors to run in a particular order. So that becomes the responsibility of the complex behavior for the children that are under it. A simple behavior, which you would have seen in some of the examples, basically just implements a task, whereas complex behaviors decide which tasks are necessary and therefore schedules them and so forth. Okay, so it decides which ones to run and then schedules them for running. Complex behaviors are quite sequential in that if you think of even how they run the different behaviors, they will schedule them on a particular sequence based on a particular decision to run them a particular way. And then you also got the composite behavior, of which to be able to run these complex behaviors and simple behaviors, the composite behavior class is very important. Okay, so let's just look at this. I hope it's quite visible, but it's quite there in your book. So at the very top, you'll notice that we've got the behavior, which we already know by now that the action and done are your standard methods that one would require for that particular behavior. And then we start discussing composite behavior and simple behaviors. When you look at the composite behavior, you'll notice that under it, it's got children like serial behavior, parallel behavior, sequential behavior, as well as FSM behavior. So these methods would normally come automatically. But like I've already said about composite behaviors, you'll notice that it already has the ability to schedule who should be first, who should be next, as well as check determination and do many other things in there because it manages that process. Whereas when you look at simple behaviors, on the other hand, it's got under it the behaviors that you're already familiar with, which is your one shot and your cyclic behavior, and more on the general side of things. You also have got the ticker behavior and the wake up behavior, which you're already familiar with. right? And you'll also notice some of the methods that are under these behaviors that are quite important. For instance, on the workout behavior, the on wake is important, whereas the on tick is important on the ticker behavior one. But these, of course, have to inherit your action and done behaviors from the simple agents, which the simple behavior itself, it in turn inherits from the main behavior class. Okay, so that is basically a high level discussion of the Jade behaviors hierarchy, and particularly I wanted to focus mostly on the composite behavior, which as you'd see, we spoke about composite behavior as well as the simple behavior and what makes them up. Okay, having spoken of composite behaviors, the next type of behavior I want to talk about is threaded behavior. I mean, people who have done advanced Java will know about the threading in Java. So when you talk about behavior scheduling, in particularly with threaded behavior, it is performed in a non-preemptive fashion. You will then use the action method of a behavior to secure almost an entire thread so that that behavior is not interrupted. The challenge with that, though, is that because it must not be interrupted, you would have blocked that whole agent on that particular thread, and you can't therefore release that particular thread. Whereas the benefit could be more on performance and scalability. Remember, when you use the action method on a thread, the advantage of using behaviors is that behaviors the action method can easily switch and quickly switch between different behaviors. In contrast, rather much faster than one will be able to switch from one thread to another. So there's generally a benefit that with the action method, when you are in a thread, when you are in any behavior, you can quickly switch on a particular thread between, still keeping the thread, but switch between different behaviors, other than having to run behaviors on different threads. So you get much better speed because of the behavior method using action than you would on a traditional threading environment. Okay. So with a threaded behavior, these are executed in a dedicated thread. Like I told you, they are never interrupted and they block the entire agent. And that, I mean, can obviously be quite a problem sometimes if you have got issues with the number of threads that you have available on your thread pool. Because for a behavior that executes long, to have a fully dedicated thread and not interpass and allow others to use that particular thread when it's not, for instance, actively using that particular thread is quite a problem. To use that, you'll then need to import the j.call.behaviors.threaded behavior factory class, which basically wraps a normal Jade behavior into a threaded behavior wrapper. Okay, so threaded behaviors can be mixed with your typical normal behaviors inside composite behaviors. Okay. Now, this is quite an interesting concept, and I think this will be also very important for the project that you will have to do before the end of the semester. Being able to start Jade from an external application. I mean, for demonstration purposes, I wouldn't expect you to be going to the IDE and then starting Jade directly there, but I would rather most likely want to see you being able to use Jade or software agents in the context of a broader project where you invoke agents to just perform a particular task and you shield them and abstract them in a way. So it is necessary to start one or more Jade agents from external applications for the reason that I've just indicated. And I mean, in an organization, people would normally, even if you have software agents, not know about it because it's abstracted by a normal system. Okay. So in-process interface basically allows Jade to be used as a library to allow the Jade runtime to be launched from within internal programs. The package that you'll require for that is the j.code.runtime class. Okay, to be able to have that in-process interface ability to call Jade from any other application. You can use the create main container or the create agent container. Remember, the main container is the must for one to have, because that's the basic that you can have basically to house agents. But agents could also be added to a normal container, but you cannot have a normal container without having a main container. So it's important to note those two. For instance, if you wanted to, if I asked you to demonstrate using an external application, the migration of agents from from the main container to another container, which perhaps was empty, this will then become quite important. Okay, and I've asked that question in the past actually. So take note. There's an example on page 112 of the prescribed book, which I'd like you to look into, because this is very important and I cannot overemphasize this. In conclusion, we've looked at content and ontology languages as important for ensuring communication between agents. We've also seen that Jade does provide classes for building ontologies. Agents can also be implemented using composite behaviors. We also had the privilege of looking at threaded behaviors, which are quite essential to overcome the blocking limitation of various behaviors. It is also possible to start Jade rather from an external Java application, and we have seen that you need the runtime package to be able to do that. Okay. There's an exercise that I'd like you to look at. Please look at. You can now pause the video and do this exercise, and once you're done, you can then move on to the next. You can continue the video to look at possible solutions, and these are not cast in stone, they're just indicative, and I would hate to see exact solutions like that, but keywords and key things you can be able to extract from that and then write in your own words when you ask similar questions in class. Okay, so those are just some of the possible solutions, and your book, obviously, you know, is quite important, and I would like you to please go and look at chapter 5 to be able to refresh your mind and take ownership of the content presented in this video lecture. With that, I want to thank you for your time and all the best. Keep safe. Goodbye.